Simplify. Assume all variables represent non-negative real numbers. 3 times the square root of 27x minus 4 times the square root of 48x plus 2 times the square root of 3x. Now, these terms are not alike at this point because we have different radicand values. Those are the things underneath the radical symbols. But we can simplify a couple of terms here by pulling out perfect square factors. Let's look at this first term. Now, 27 has a perfect square factor of 9. So let's rewrite this as 3 times the square root of, in place of 27, let's put 9 times 3, then times x, minus, with our second term, 48 has a perfect square factor of 16. So this middle term becomes 4 times the square root of 48 is 16 times 3, and don't forget your x value under there. Lastly, this term is in its simplest form, so let's just rewrite it. 2 times the square root of 3x. Now as our next step, let's pull those perfect square values out of the radicals. The square root of 9 is 3, and 3 times the 3 that is already in front gives a product of 9. So that 9 came out, but the 3x stays underneath. So let's write that as 9 times the square root of 3x minus the square root of 16 is 4. So out comes a 4. Times 4 gives 16 as the number outside the radical. 3x stays underneath. And lastly, let's just again rewrite that last term. 2 times the square root of 3x. So what we see here are 3 terms that are indeed alike. They each have the square root of 3x in them with a single numerical coefficient out front. So let's combine the coefficients. 9 minus the 16 is a negative 7, plus 2 gives a negative 5 times the square root of 3x. So our simplified form is negative 5 times the square root of 3x.